Sec 2 Mathematics, Chapter 8, Trigo Ratios of Acute Angles. In this part of the chapter, we'll be looking at the relationship between two sides and an acute angle of a right angle triangle. There are three different types of trigo ratios, namely sine of an angle, acute angle, cosine of an acute angle, and tangent of an acute angle. In this part of the activity, we'll be looking at the tangent ratio. In the diagram, we have three different sized right-angled triangles. What do you notice that is common about these three different triangles? Well, every one of them has an angle 60 degrees, and we shall use this as our reference angle in this experiment. Before we begin, we will need to find the ratio of the opposite side and the adjacent. But where is the opposite side and where is the adjacent? Taking a look at triangle ABC, where the angle BCA is the 90-degree angle, we will be able to label the hypotenuse AB. With respect to the angle, reference angle 60 degree, angle BAC, where is the side that is opposite to this angle? BC is the opposite. And where is the side that is adjacent to the angle BAC? AC is the adjacent. Now, will you be able to write down the ratio of the opposite side over the adjacent side by finding the value given? So what do we have? We will have the opposite side, which is the letter O, to be 8.65, and the adjacent side to be 5 cm. Calculating this value, we get a value of 1.73. Let's remember this value 1.73. Let's take a look at the next triangle, DEF. What do you think will be the value or the ratio of the opposite side over the adjacent? In triangle DEF, where DEF is the 90-degree angle, we will have the hypotenuse to be DF, and with reference to the 60-degree angle, we will have the side opposite to it, EF. And last but not least, we will have the side DE to be the adjacent. What is the value of the ratio of the opposite side to the adjacent? Using these values, we will have 3.46 and over 2, and by calculation, we'll get the value to be 1.73. What do you notice? Can you complete the trigo ratio for the last triangle on your own? Similarly, for triangle XYZ, we will have XZ as the hypotenuse with reference to the 60-degree angle, YZ to be the opposite, and XY to be the adjacent. Taking the trigonometric ratio for the opposite over the adjacent, we will have 6.92 over 4. And again, the value is 1.73. So what do you notice about the ratio of opposite sides over the adjacent side in right angle triangles as the length of the sides changes while keeping the angle the same? This ratio, where we take the opposite side over the adjacent side, is constant no matter how the length of the sides changes. This is known as the tangent ratio. Use the calculator and find out the value of tangent 60. Can you find TAN tangent button on your calculator screen? Press tangent followed by 60. And you'll be able to get the value 1.732. If we were to round it off to 3 feet, we will have 1.73. What do you notice about the value for these three numbers? And tangent 60. They are all the same because tangent of an acute angle is given as taking the opposite over the adjacent, and hence we form the tangent ratio. In general, for any right-angled triangle, the tangent of a given angle is given by the ratio opposite over adjacent, TOA. Let us now look at the cosine ratio of three different triangles, right-angled triangles with a common angle of 60 degrees. Similarly, we need to label the different sides of the triangle with respect to a given angle 60 degrees. So we will have in triangle ABC, the side opposite to the hypotenuse, opposite to the angle ABC is H, the hypotenuse. Identifying the angle, we will have 60 degrees here, and the side opposite to 60 degrees will be BC as O, and last but not least, AC as adjacent A. Write down the ratio of the adjacent sides over the hypotenuse. What can you find? The adjacent is 5 cm, the hypotenuse is 10, and we get the value 0.5 or half. What do you think will be the values for the other three ratios? Can you work them out? The other values will be 2 over 4, which is 0.5, 4 over 8, which is still 0.5. What do you notice about the ratio of the adjacent sides over the hypotenuse in a right-angled triangle as the length of the sides changes while keeping the angle the same? This ratio, taking the adjacent over the hypotenuse, is constant no matter how the length of the sides changes. This is known as the cosine ratio. Use your calculator to find out the value of cosine 60. Are you able to find the COS button on your calculator? Type in cos 60 and you will get the value 0.5. What do you notice about the value of cosine 60 with the ratio of adjacent over hypotenuse. All these values are 0.5. Therefore, in general, for any right-angled triangle, the cosine of a given angle is given by the ratio adjacent over hypotenuse. Cosine of the angle is given by the ratio adjacent over hypotenuse. Let us look at the last trigo ratio, the sine ratio. Inside this sine ratio, similarly, we will need to label the different sides of the triangle with respect to their common angle, 60. And we will have, this is the 90-degree angle, so this is the hypotenuse. With respect to the angle 60, we will have this to be the opposite, and this side here, AB, to be the adjacent. In the sine ratio, we are going to look at the sides opposite over the hypotenuse. Fill in the values and find out the ratio of this pair. We will have opposite to be 8.65, the hypotenuse to be 10, giving us a value of 0.865. Can you fill out the values? Can you fill in the values for the other triangles? We will have the value 3.46 over 4, which gives us 0.865. And for this side, we will have 6.92 over the hypotenuse 8, which will also give us 0.865. What do you notice about the ratio of opposite sides and the hypotenuse in these right-angled triangles, as the length of the sides changes while keeping the angle the same? Now the ratio of the opposite over the hypotenuse is constant no matter how the length of the sides change. This is known as the sine ratio. Using the calculator, find out the value of sine 60. Are you able to find the sine button, SIN, on your calculator? Press sine 60 and you will get the value to be 0.866, corrected to 3 secant figures. Now what do you notice about the value of sine 60 and the ratio of opposite over hypotenuse? All these values are very similar, and they are approximately equal to 0.866. In general, for any right-angled triangle, the sine of the angle is given by the ratio opposite over hypotenuse. Repeat again. Sine of an angle is given by the opposite over the hypotenuse. And hence, we conclude that we have the trigo ratios for sine angle, SOH. Sine of the angle is opposite over hypotenuse. Cosine of the angle, CAH, which is cosine of the angle is the adjacent over the hypotenuse. And lastly, tangent, TOA, which is tangent of the angle is opposite over adjacent. Together, we form the TOA, CA, SO, which in Hokkien it means TOA, the big, CA, foot, SO, lady. so it's the big foot lady.